Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin.
Imagine holding up a mirror not to your face but to the tiny pieces that make everything you know. In that mirror, every charge flips like a shy smile turning the other way. What was plus becomes minus. What was left becomes right. What was ordinary becomes a ghostly partner. Scientists call this partner antimatter. It sounds sharp, like a secret blade, but in truth it is simply the other side of what we already are. It is the echo to our voice, the footprint to our foot, the shape that would fit us perfectly if the world suddenly turned inside out. In our everyday life, we meet matter everywhere. Your hands, the rain, the bread you eat, the page you read from, the dust falling through a beam of light, these are made from particles with familiar charges and behaviors. An electron carries a tiny negative charge. A proton carries a tiny positive charge. Neutrons carry none. But in the soft mirror of nature, each of these has a twin. The electron's twin is the positron with the same mass but the opposite charge. The proton's twin is the antiproton. Positive becomes negative, and negative becomes positive. Even neutrinos, which are like whispering ghosts that pass through your body by the trillions each second, have their gentle partners. Antimatter is not make-believe. It appears in the world whenever energy is bright and crowded enough to make new things. On the skin of Earth, when high-energy particles from space kiss the air, little sparks of twin-making can happen. In lightning, which is a sky's fast river of charge, scientists have seen hints of positrons, the light-footed twins of electrons, slip out like moths escaping a jar. In medical rooms, doctors use antimatter quietly to see the inside of the human body in a scan that follows the tiny flash of a positron meeting an electron. In large rings built by patient hands and clever minds, particles are pushed to near the speed of light, and for a breath of time, pairs of matter and antimatter are born, like twins opening their eyes at the same moment. If matter and antimatter are twins, why do they not live side by side? The answer is both simple and strange. When an electron and a positron meet, they do not bounce off each other like marbles. They share a final hug and vanish in a blink of light. Their mass becomes energy, two little flashes, usually high-energy light called gamma rays, racing away. This is not anger or war. It is a rule of nature as calm and firm as gravity. It is like two opposite notes that, when played together, make a perfect quiet. The quiet is not empty. Its hush is filled with light. That light carries away the story of their meeting. This rule makes antimatter seem dangerous. If a spoonful of antimatter touched a spoonful of matter, the flash would be brighter than any kitchen could hold. It would be more energy than we can easily hold in our heads. Because of this, antimatter carries a reputation like a tiger's stripe, beautiful but warning. Yet the world keeps us safe for a simple reason. Free antimatter is very rare here. It is short-lived in our ordinary air and water. The moment it appears, it meets matter and ends in light. To keep antimatter, we must float it like a bubble in a kind of wind that it cannot cross. We do not put it in jars or boxes. We hold it with fields and emptiness, using magnets to cradle charged antiparticles so they do not touch the walls. If you have ever tried to hold a soap bubble on your palm and found it bursts at the slightest touch, you know the feeling. Antimatter must not touch what it mirrors, or it will become light and be gone. To think of antimatter, place a single seed in your mind. Everything has an opposite that fits it exactly. Picture two puzzle pieces that look the same shape but carry opposite colors. When they press together, their colors cancel and give off a glimmer. Picture a dandelion clock in the evening, half its seeds gone. The white tufts that remain are matter. The ones the wind took are like antimatter, not here anymore, but their absence reminds you that they once were. Nature has both, but our world, the everyday floor beneath your feet, was built with more matter than antimatter, as if the universe tilted a little during its earliest moments and let one side spill over. In the very beginning, when the universe was young and thick as soup, energy and particles danced together in a hot, crowded hall. In that heat, matter and antimatter were made in pairs. For every electron, a positron. For every proton, an antiproton. They met and hugged and turned into light, and new pairs formed from that light again, over and over, like waves rolling onto the same shore. If everything had stayed perfect, the whole universe might have become only light, a sea of energy with no islands of stars and planets. But something small and secret happened. For reasons scientists are still gently untangling, there was a tiny extra pinch of matter, just a few grains more in every great pile. Of pairs, that tiny difference, like one more drop in a bucket, was enough. When almost everything turned to light, that slight extra was left over. From that leftover matter came clouds. From clouds came stars. From stars came heavy elements and worlds and oceans, and the small, quiet lives that look up at night and wonder why there is something instead of nothing. Antimatter helps us remember that the world we walk through is balanced by an invisible twin that we cannot easily keep, but we can see its fingerprints. In the sky, satellites watch for sudden bright flashes, and sometimes they find the sharp cough of gamma rays, a sign that an electron met a positron. In labs, detectors are built like careful ears that listen for tap-taps of particles and their opposites. In hospitals, a special sugar carries a positron. It travels through the body like a messenger bird. When the positron meets an electron, there is a soft burst of light. Machines read that light, and doctors draw maps that show where cells are busy and where they are calm. In this way, a rule of vanishing becomes a tool for care. The most dangerous thing becomes gentle in our hands. To keep antimatter for longer than a blink, we learn to make quiet rooms. These rooms are not rooms you can enter. They are cages made of fields empty of air where magnets curl like invisible fingers to make a cradle. Charged antiparticles can be held in these cradles because they feel the magnets tug. They circle and circle, kept away from the walls. Neutral antimatter, like antihydrogen, the twin of the simplest atom, needs a more delicate touch. It is held by subtle changes in magnetic strength, caught in a soft valley where it can drift without touching. Think of catching a snowflake on a web that is so fine you cannot see it. The snowflake rests for a heartbeat, and then it is gone. That is how we keep antimatter, with patience, with quiet, with respect for how quickly it returns to light. When people hear that antimatter turns to energy, they sometimes imagine it as a new kind of fire, a future engine, a perfect fuel. It is true that mass turns into energy with great efficiency when matter meets antimatter. But the universe does not give us jars full of it. We must make it, and making it costs more energy than we could ever gain by letting it vanish again. It is like building a sandcastle one grain at a time and then watching a wave dissolve it. You can do it for beauty or to learn how waves move, but not to power a town. So antimatter is dangerous in the way a thunderstorm is dangerous, not because we can bottle it for harm, but because the rule behind it is powerful and cannot be tricked. The danger is in misunderstanding, not in the tiny amounts that touch our lives. Perhaps the most soothing thought is this: antimatter is not the enemy of matter. It is the poem that balances the poem. It is the silence that makes the song feel whole. If the universe carries deep laws, one of them is that every pattern has a mirror, and the mirror is not less real than the pattern itself. When we think of antimatter, we are really thinking about symmetry, which is a careful word for balance. A butterfly's wings are symmetric. Your hands are symmetric. Many of nature's rules are symmetric too. Antimatter is the way particles keep that promise. For every left hand, a right. For every hill, a valley. For every particle, a partner that answers with equal weight and opposite sign. Still, there are soft puzzles that keep scientists awake in the gentlest way. Why did the universe show favor to matter in the first dawn? Why do particles and antiparticles sometimes break the perfect mirror just a little in their dances, as if winking? Where do free positrons in thunderstorms go, and how many pass through us without us ever feeling them? These questions are not loud. They are slow river questions. They bend around rocks and carry leaves. They take time. We answer them by building magnets that hum like bees, by listening for flashes of light in halls as quiet as libraries, by watching the sky for the quick handwriting of cosmic rays. You can feel the comfort of knowing that you, made of matter, are safe in a world that prefers matter. You can also feel the wonder that your body is open to its own mirror for a moment when a doctor uses positrons to see your inner garden. Somewhere, an electron in a cell meets a positron, and for an instant they become light that tells a story to a machine, and the machine tells a story to a healer, and the healer tells a story to you. Here is where you are strong. Here is where we must care for you. The rule of vanishing becomes a rule of seeing. Now imagine holding a small glass bead up to the sun. The bead bends the light and makes a tiny bright ring on the ground. Antimatter bends our thoughts like that bead. It makes us notice how light and mass and charge meet and part. It shows us that even opposites are part of one whole. Etik. He's caution because a meeting can be a goodbye, but it also teaches gentleness because even that goodbye leaves light. As the day cools and the sky deepens, let the idea rest. Antimatter is the soft mirror of the world. It is rare in your hands, but not rare in the rules that guide the stars. It flickers in the upper air, it hums in machines built with care, it whispers in the images that help doctors heal, and it sings in the story of the first dawn. Dangerous, yes, in the same way the sea is dangerous, endless, powerful, honest, but also beautiful because it tells us that nature cares about balance. The world was born from that balance, and even now, in every quiet place, the light from 1,000 tiny meetings still runs outward, stitching the dark with threads we cannot see, tying the mirror and the face together softly forever. If antimatter is the mirror that vanishes, then section 2 is where we lean closer to that mirror and watch how it bends the light of our thoughts. We already know that when matter and antimatter meet, they dissolve into pure energy. But what happens when we ask not just how, but why? The answer is not a single note, but a soft chord made of physics, symmetry, and the patience of human discovery. Imagine a meadow filled with flowers, each facing the sun. The meadow is full of balance. For every petal leaning right, another leans left. That is how physicists see the deep laws of nature, as meadows of symmetry. Antimatter is part of that meadow. For every electron, there is a positron, its mirror image, so that the pattern feels complete. This is not decoration. It is the very way equations stay honest. When scientists write down the mathematics of the quantum world, if antimatter did not exist, the equations would feel broken, like a poem with missing rhymes. Antimatter was not invented in a lab. It was discovered first in the whispers of mathematics, as if the universe had written its secrets in symbols before we ever built machines to see them. In 1928, a quiet man named Paul Dirac wrote down an equation to describe electrons. His pencil moved across paper, line after line, until he found something unexpected. His equation said electrons could not only have their familiar form, but also a twin with the same mass and the opposite charge. At first, this seemed like a strange ghost in the math. But in 1932, a positron was seen for the first time in a cloud chamber, a little curved track of vapor revealing its dance. The mirror had been real all along. What was once a symbol on paper became a trail of light in a box of mist. That is the poetry of science, ideas drawn in silence that later bloom into visible truth. As decades unfolded, experiments kept showing us that antimatter is not fantasy. Cosmic rays falling from the sky carried positrons. High-energy collisions produced antiprotons. Entire atoms of antihydrogen, delicate twins of hydrogen, were coaxed into existence. Each discovery added a new verse to the poem of mirrors. Yet the central puzzle remained. If matter and antimatter are born in pairs, why is our universe so full of one and so empty of the other? Why does the mirror seem broken in the large scale, even though it is perfect in the small? The universe carries an ancient imbalance. In the very first seconds after the Big Bang, there should have been equal parts matter and antimatter. They should have canceled each other, leaving only light. Instead, something tilted the balance just enough to let matter remain. That imbalance, tiny as a breath, became all that we see: stars, oceans, forests, and us. To understand this, physicists study particles called mesons, which are like fragile flowers in the particle garden. Mesons sometimes show a faint preference for matter over antimatter, as if they lean ever so slightly toward one side of the meadow. This tiny asymmetry is known as CP violation. It is not loud. It is subtle, like a whisper that tips the scale. It is one of the few clues we have to explain why we are here at all. Think of the universe as a story where every character has a twin. If all characters vanished with their twins, the book would end at the first page. But if a single character stayed behind, the story could unfold. That is what the universe did. It let matter linger. We do not yet know exactly why, but the search itself is a kind of lullaby, patient, curious, steady. In giant underground laboratories, detectors watch for the rarest dances of particles. They wait in silence, listening for the faint break of symmetry. When a particle betrays its mirror just a little, scientists take note, like scribes recording a secret stanza. Antimatter is not only a cosmic puzzle, it is also a tool. In hospitals, positrons are used in PET scans to map the living body. A patient receives a molecule carrying a positron. That particle wanders until it meets an electron. They vanish into light and detectors catch the glow. From these glows, doctors create IM. Ages tracing the rhythms of blood, the hunger of cells, the energy of tissues. A rule of annihilation becomes a way of healing. The most dangerous substance in the universe becomes one of the most useful in care. This is the paradox of science, danger and gentleness folded together like the two wings of a moth. In research, antimatter helps us test the very foundation of physics. If matter and antimatter are perfect mirrors, then an atom of antihydrogen should behave exactly like hydrogen. It should absorb and release light in the same way, fall in gravity with the same pace, spin with the same rhythm. But what if the mirror is not perfect? What if gravity pulls matter and antimatter differently? What if light bends them in unequal ways? Such differences could rewrite our understanding of the cosmos. To find out, scientists have built traps of emptiness magnetic bottles where antihydrogen floats without touching the walls. They shine lasers at it. They weigh it in the gentlest of balances. They watch its tiny heartbeats of light. Each result so far says the mirror is still unbroken. But the watching continues because even the smallest crack could open a doorway to new worlds of understanding. To see the delicacy of this, imagine trying to hold a snowflake steady long enough to measure its weight. The moment it warms, it melts. The moment it touches, it disappears. That is how scientists cradle antimatter, with fields, with vacuums, with care so exact that even a single atom becomes a treasure. The beauty is not in the explosions people imagine, but in the stillness required to keep something from vanishing. Meanwhile, the universe itself makes antimatter every day. In thunderstorms, positrons flash in the upper air. In the jets of black holes, particles and antiparticles are born and torn apart in storms of radiation. In distant galaxies, matter and antimatter may still meet, releasing gamma rays that travel across space to touch our detectors. Each of these events is both ordinary and cosmic. They remind us that the mirror is not empty. It is woven into the very fabric of how energy and matter converse. There is also something poetic about the way antimatter points us back to light. When matter and antimatter meet, they become photons, particles of light. It is as if the universe has a built-in rule. Opposites, when reconciled, return to radiance. In this sense, antimatter is not a destroyer but a bringer of light. It reminds us that endings are not voids but transformations. Two beings meet and vanish, but their meeting fills the dark with brightness. At night, when we look at the stars, we are already looking at light that may once have come from such annihilations. Gamma rays race across the void, carrying the memory of vanished pairs. In this way, the story of antimatter is not separate from the story of our sky. It is written in the faint glimmers that reach our eyes after traveling millions of years. To see a star is to see the poem of matter, but to see the highest energies of light is to glimpse the poem of matter's mirror as well. Let's drift deeper into thought. Suppose the universe had chosen differently. Suppose antimatter had won the early contest. Then you would be made of antiprotons, antielectrons, antineutrons. Your world would look and feel the same. Trees would grow, rivers would flow, hearts would beat, light would shine. You would not notice the difference. The danger only lies in mixing the two worlds, because where they meet, they undo one another. This thought experiment reminds us of humility. The universe we call normal is only one of two possible reflections. What we call matter is simply the side that survived. Antimatter is not unnatural. It is simply the road not taken. Science is often painted as sharp and cold, but here it is gentle and philosophical. Antimatter is both puzzle and poetry. It is the reminder that nature cares about balance, yet it also shows us that balance can be tipped. It is the partner that cannot stay, the twin that disappears in a flash, and yet in disappearing it leaves behind the most fundamental gift, light. Without that light, we could not see the universe. Without the asymmetry that left matter behind, we could not exist to wonder about it. Close your eyes and picture a pond at dusk. Dragonflies skim the surface. Each ripple spreads outward, fading into the dark. Antimatter is like those ripples, fleeting, delicate, gone in a moment, but leaving the water trembling with memory. The pond is the cosmos, and the ripples are the flashes of annihilation. They vanish quickly, but the story they tell lingers, carrying across space and time. It is this story that scientists follow, patient as listeners in the twilight, catching every tremor. As you breathe, trillions of neutrinos pass through your body, most without touching. Some may have their antiparticle forms, silent and strange. You do not feel them. You do not need to. Their presence, Ray, reminds us that the universe is full of hidden twins. You are more than matter. You are part of a world that balances itself on unseen scales. Even your existence is a kind of asymmetry, a survivor of a choice the cosmos made long ago. So let this thought rest in you. Antimatter is not only danger, not only vanishing, not only puzzle. It is the gentle proof that the universe is written in mirrors. It is the echo to every note, the reflection in every pool, the opposite wing that makes the butterfly whole. To hold it in mind is to feel the balance of creation itself. The mirror is always there, even if the image slips away. We have wandered through the meadow of antimatter's balance and leaned into its shimmering mirror. Now let us bring the story to a gentle close, not with final answers, but with the kind of quiet reflections that settle like dew at dawn. To understand antimatter fully, one must step back and see it not just as a substance, but as a lesson written across the fabric of existence. Imagine again the beginning of everything, the universe as a newborn, still glowing with heat. In that first instant, matter and antimatter were born as equals, twins hand in hand. They danced together and most of them dissolved into light. Only a few grains of matter survived, just enough to make all the galaxies, stars, and lives we now know. That survival is the reason your heart beats, the reason oceans stretch under the moon, the reason mountains rise against the sky. The story of antimatter is not only the story of what vanished, it is the story of why you exist at all. This makes antimatter a paradox of both absence and presence. It is mostly gone, but its absence shaped the world. It is dangerous in theory, yet rare in practice. It is fleeting, yet its traces echo through cosmic rays and gamma flashes that touch our detectors even now. Like the shadow of a bird that has flown on, antimatter's outline remains, telling us it was once here, and that it still waits at the edges of our knowing. Scientists are not content with shadows alone. They build great machines to call antimatter back, even for moments. In long tunnels underground, particles are accelerated and smashed together, producing pairs of matter and antimatter in tiny, controlled storms. Each annihilation gives off light that detectors read like a poem. In labs where silence is prized, magnetic fields hold anti-atoms, trying to weigh their behavior against hydrogen's familiar steps. The patience needed for such experiments is immense. It is the patience of gardeners, tending not to trees or flowers, but to the rarest seeds of the universe. These seeds vanish almost as soon as they appear, yet from their brief lives, whole chapters of physics are written. But perhaps the greatest gift of antimatter is philosophical. It teaches us about balance and about fragility. The symmetry of nature is deep, yet it was tipped ever so slightly to allow the cosmos we see. Without that tipping, without that faint favoritism toward matter, nothing would remain but endless radiation. you and I would not be here. Every question you have ever asked, every laugh you have ever shared, every dream you have ever carried, they are all the consequence of a broken mirror. The universe was almost even, but not quite, and in that not quite lives everything. This realization is humbling. It suggests that existence itself is precarious, balanced on a knife's edge between being and vanishing. It makes every breath a kind of miracle. You are here because of a tiny flaw in symmetry, and so is the tree outside your window, and so is the river that runs across stone, and so is the star that burns far away in the night sky. Antimatter, in vanishing, made room for all of this. In daily life, we rarely think of such fragile balances. We wake, we work, we sleep, and the mirror world of antimatter seems distant, yet its touch lingers. Each PET scan in a hospital is a reminder. Each gamma flash from a thunderstorm is a reminder. Each cosmic ray hitting the atmosphere is a reminder. The universe whispers, there is always another side, even if you cannot see it. There is a quiet poetry in imagining that somewhere far away, there might be regions of the cosmos where antimatter is not rare but abundant. Whole galaxies of antimatter stars, burning as brightly as our own, their light indistinguishable from the light of matter stars. If such places exist, they are too distant for us to know. But the thought is soothing. Perhaps the mirror was not entirely lost. Perhaps it shines elsewhere, writing a parallel story, silent across the gulf of space. Antimatter also teaches us the beauty of transformation. When it meets matter, it does not leave emptiness. It becomes light. Endings become beginnings, and disappearance becomes illumination. This is not destruction, but change, the way autumn leaves fall to feed the soil, the way waves return to the sea. The lesson is simple: even opposites can create something radiant together. Even final hugs can leave behind brightness. Now picture yourself standing in a quiet field under the night sky. The stars above you are steady, ancient, patient. Somewhere in that light lies the memory of matter and antimatter's embrace. Every photon is a messenger from such unions. The light touches your eyes and you become part of the story. You are not separate from the mirror. You are written into it, living on the side that remained, yet always reflecting the side that was lost. As we bring this story to rest, let us not focus on danger, but on wonder. Antimatter is often called the most dangerous substance, but danger is only one word for a truth much deeper. It is fragile, fleeting, balanced, radiant. It reminds us that nature values symmetry, but also that perfection can break in ways that allow life. It reminds us that even when things vanish, they can leave behind light. It reminds us that the universe is more mysterious than we can hold, yet gentle enough to reveal its secrets one by one. Close your eyes and feel the weight of this. You are here because the mirror cracked. You are here because opposites once met and mostly canceled, but not entirely. You are here because of a tiny imperfection in the deepest rules of creation. That imperfection is not a flaw, it is a gift that carries oceans and skies and quiet nights, a gift that allows us to sit together in thought and whisper about vanishing twins. So let the final image be this: a mirror pond at dawn. The surface is calm. A dragonfly hovers. For a moment the reflection is perfect. Then a leaf drifts across, breaking the symmetry. The mirror ripples. The reflection is not lost but changed. You are that leaf. This universe is that ripple. And antimatter is the mirror beneath it all, still there, still waiting, still reminding us that even when symmetry breaks, beauty remains. The story of antimatter does not end with its mirror vanishing. It continues in the quiet drama of collisions, where matter and antimatter meet, not in hatred, but in union. When they touch, they release their entire being into light. This release is so pure, so absolute, that it feels almost like a prayer whispered by the universe itself. To stand in thought before such a process is to feel the hum of creation and disappearance woven into one. Imagine two fireflies in the dusk. One glows with familiar light, the other with its opposite. When they drift together, their glow does not double, it transforms. They disappear, and in their place a new brightness is born. This is what happens when matter meets its shadow. It is called annihilation, yet the word does not do justice to its tenderness. The particles do not scream as they vanish. They simply merge, and in merging they become photons, tiny messengers of light that stream away in opposite directions. In that transformation, we glimpse one of the deepest rules of nature. Energy is never lost, only changed. Scientists have spent decades learning to understand these gentle vanishings. They build detectors that can watch for the instant when a particle and its twin collide. In a fraction of a second, two specks of mass are gone, but two flashes of light are born. Those flashes, usually gamma rays, are incredibly energetic. They can travel across space untouched for millions of years. Some of the gamma rays that reach Earth tonight may have begun their journey in the hearts of galaxies, where antimatter and matter embraced in quiet fireworks. The night sky in this way carries a secret. It glows not only with the light of stars, but with the echoes of vanishing twins. But let us draw closer to the science itself. When an electron meets a positron, the most common annihilation produces two gamma-ray photons. They race away in opposite directions, conserving the balance of momentum. It is a kind of choreography written into the fabric of physics. Nothing is wasted. The particles are gone, but their energy moves forward, woven into the universe as light. It is in this transformation that Einstein's quiet equation, E equals mc2, comes alive. Mass becomes energy. Substance becomes radiance. The equation is not just math on a page, it is the universe itself, singing softly through the annihilation of twins. In the laboratory, this process is more than a curiosity. It becomes a tool. Positron emission tomography or PET scanning depends on annihilation. A tiny amount of a positron-emitting substance is introduced into the body. The positrons travel only a short distance before meeting electrons. When they do, the resulting gamma rays stream away in perfect balance. Detectors catch the light and build an image from it. In this way, annihilation does not mean destruction. It means seeing, healing, guiding. The body's hidden rhythms are revealed by the most delicate of vanishings. It is hard to imagine a more poetic transformation, the universe's deepest balance helping us to care for fragile life. But beyond medicine lies the cosmos itself, where annihilation is not rare but constant. At the edges of black holes, where matter spirals inward, conditions grow so extreme that particles and antiparticles are born. They meet, they vanish, and in their vanishing, they pour out energy that we can detect across vast distances. Some gamma-ray bursts, the brightest explosions ever seen, are thought to be fueled in part by these annihilations. They light up the universe like sudden lanterns in the dark, telling us that even in the most violent events, the quiet rule of matter meeting antimatter plays a role. It is strange to call these annihilations dangerous. They are powerful, yes, but they are also part of the natural rhythm of existence. Without them, we would not see into the body with clarity. Without them, we would not detect the distant fireworks of galaxies. Without them, the balance of energy and mass would remain hidden. Danger is only one name for them. Another name is transformation. Another name is truth. Now imagine yourself drifting slowly in orbit, far from Earth. Below you, the planet glows with thunderstorms. Each storm sends up flashes of light, and within those flashes, scientists have discovered positrons. Yes, antimatter is born in our own skies in the crackling dance of lightning. These positrons meet electrons, and annihilation flashes follow. They are small, too soft for us to feel, but satellites above Earth can catch them. The atmosphere is not only water and air. It is also a theater where matter and antimatter meet in whispers of light. To think of this is to feel a kind of comfort. Annihilation is not something foreign. It happens above us in every storm. It happens inside us in every PET scan. It happens in the cosmos as galaxies burn and fade. It is woven into the world in the same way as the rising of the sun or the falling of rain. It is not war. It is balance, not loss but change. The language we use, annihilation, carries sharpness, but the reality is softer. It is two halves becoming whole again, two mirrors returning to the same light. There is also something deeply spiritual in the way this process reflects back on us. We too are pairs of opposites. We carry light and shadow, strength and fragility, laughter and silence. When opposites within us meet, they do not always destroy each other. Sometimes they make us whole. Sometimes they give birth to new light. Antimatter in this way is more than physics, it is metaphor. It is the reminder that opposites are not enemies, they are partners in a dance that ends in radiance. As we close this first section, let us rest with this thought. The soft thunder of light is always near. It is in the sky, in the body, in the cosmos. Every time matter meets antimatter, the universe whispers the same truth. What seems like an ending is also a beginning. The particles vanish, but their light travels on, carrying the memory of their meeting across space and time. If you look at the stars tonight, you may be touched by such a photon, a silent messenger born from a union long ago. And in that moment, you too are part of the story, glowing softly in the balance between matter and its shadow. The soft thunder of light does not fade after one flash. It carries on, echoing across the universe in ways both small and grand. To follow it deeper is to follow the path of annihilation wherever it appears, from the tender spaces inside the human body to the vast storms of distant galaxies. Each meeting of matter and antimatter is a kind of whisper written in light, and when we listen closely, we discover how the cosmos itself is stitched together with these vanishing sparks. Think first of the laboratory, where scientists build their instruments to cradle annihilations with care. In these quiet rooms, positrons and electrons are brought together deliberately. The flashes they create are caught by detectors that do not sleep. The patterns of those flashes reveal truths. The directions the photons travel, the exact energy they carry, the timing of their release. Every detail adds to the picture of how nature balances itself. For decades, experiments have shown the same soft law. When matter meets its shadow, the balance is always perfect. Energy is conserved, momentum is conserved, nothing is wasted, nothing is broken. The meeting is precise, as if the universe itself insists that even in vanishing, order must remain. Now drift outward from the laboratory to the hospital, where this same process becomes a gift of healing. A patient lies still, breathing softly, as a tracer containing positrons begins its journey inside their body. The positrons wander until they find electrons, and the quiet thunder follows. Each annihilation gives off a pair of gamma rays flying in opposite directions. Detectors ring the patient, listening for those pairs of photons. Each detection is a word in a sentence, and as the words gather, an image takes form. Doctors read this image not as poetry, but as maps of life. They see where cells burn brighter with energy, where tissues rest, where growth stirs. What for the particles is an ending becomes for us a way of knowing. Annihilation is not destruction, it is illumination. Step further out again into the sky above. Every thunderstorm you have ever seen has been more than lightning and rain. Within the flash of a bolt, positrons are born. They dart upward, meeting electrons in the air. The result is light invisible to your eyes but caught by satellites far above. Earth storms, then, are not just weather. They are laboratories of antimatter, reminders that the cosmos is generous in its creations. The next time you watch lightning fork across the clouds, you can imagine a hidden counterpart, tiny twin vanishings that leave their signature as light. The storm is not only noise and brightness, it is a quiet stage where matter and antimatter share their final embrace. But beyond storms and hospitals lie the deeper theaters of annihilation, the hearts of galaxies. Near black holes, particles are born in such great energies that their shadows appear alongside them. Matter and antimatter swirl together in jets that pierce space. When they meet, they release gamma rays that travel across the universe. Some of the brightest bursts of light we have ever seen, gamma ray bursts, owe part of their ferocity to this process. They are not simple explosions. They are symphonies of creation and disappearance, of particles and antiparticles meeting at the edge of possibility. To witness such light, even from far away, is to be reminded that annihilation is not rare. It is woven into the structure of the cosmos. Even the quiet sea of empty space is not empty at all. In the quantum world, the vacuum seethes with pairs of particles and antiparticles popping into existence and vanishing again in less than the blink of an eye. They are called virtual particles, and though they cannot be touched directly, their presence shapes reality. They affect how forces act, how atoms bind, how light bends near great masses. The vacuum is not silence. It is a murmur of fleeting annihilations, constant and unseen, a soft thunder everywhere always. When you look into the night sky and think of emptiness, remember that the void is alive with the faint shimmer of particles meeting their shadows and fading again into nothing. This constant vanishing carries lessons for us. It shows that change is the most natural state of all. Matter does not cling to itself forever. Antimatter does not linger in defiance. They are drawn together, and in their meeting they let go. That letting go becomes light. We too are creatures of change. Cells are born and die within us every day. Thoughts flicker and vanish like virtual particles. Our lives are woven of arrivals and departures, of meetings and dissolutions. To think of annihilation is to think of our own cycles, quiet and unstoppable. Yet, like the particles, we do not simply vanish. We leave light behind in memories, in kindnesses, in the echoes of our presence. The physics becomes philosophy, and the philosophy becomes comfort. One might imagine that if antimatter were abundant here, the world would be a place of constant danger. But the truth is that nature guards us from such abundance. Antimatter exists, but only briefly, only in flashes. We cannot scoop it up with our hands or store it in jars. The universe allows it to appear, but ensures it will vanish almost at once. It is a reminder that some treasures are meant not to be possessed, but to be glimpsed, to be honored, to be understood. That is why scientists do not try to harvest antimatter for power. To make it requires more energy than it can return. Its value lies not in utility, but in truth. It is a lens through which we see the hidden balance of the cosmos. As we follow this soft thunder through the body, the storm, the galaxy, and the vacuum, we begin to see that annihilation is not the end of the story. It is part of the ongoing rhythm of the universe. Light travels on after the particles are gone. It carries their memory. It carries their balance. It carries their essence. When you stand under the stars and feel the night settle around you, some of the light reaching your eyes is born of these vanishings. You are touched in that moment by events where matter and antimatter became light. The cosmos speaks to you through these photons, softly, gently, across millions of years. And so the soft thunder of light is not distant. It is here always in your body, in your skies, in the quiet between stars. Every annihilation, no matter how small, is a thread in the tapestry of existence. To see it as dangerous is to see only half the picture. To see it as beautiful is to see more deeply. It is the balance of opposites, the meeting that becomes radiance, the whisper that carries across the universe. In its constancy, it comforts us. In its mystery, it inspires us. And in its inevitability, it reminds us that even endings are woven with light. The story of annihilation has carried us from the stillness of laboratories to the roar of galaxies, from the quiet body to the wild skies of storms. To bring this journey to its resting place, let us now linger on what it means, not just for science, but for us as beings who live between shadow and light. When matter meets antimatter, it vanishes, yet the vanishing is filled with radiance. What begins as an end becomes a continuation. This is not only physics, it is a metaphor written into the universe itself. Imagine standing on a cliff at dawn. The horizon glows, though the sun has not yet risen. That light is not the sun's body, but its promise traveling through air and cloud before the star itself appears. Annihilation is much like this. The particles themselves do not remain, but their promise does. The photons born from their union carry the message forward. They travel across time and space, arriving long after the particles have gone, arriving long after the meeting has ended. It is a reminder that our actions, too, send out ripples that move on beyond us, even when we are no longer present to see them. In science, annihilation is exact and measurable. Each photon has a known energy. Each angle of release follows a rule. But in poetry, annihilation is also a symbol. It speaks of opposites that complete one another, of endings that are also beginnings. Two halves cancel, yet from their cancellation light is born. Perhaps this is the deepest lesson antimatter gives us, that what looks like destruction is often transformation, and what looks like silence may in fact be the start of a song. Think of black holes again, those dark hearts of galaxies where matter falls and annihilation hums in the storm. Out of that chaos come streams of light visible across millions of years. The most violent environments create the most luminous signatures. And yet the principle is the same as in a hospital PET scan, as in a thunderstorm above Earth. Matter and antimatter meet, vanish, and in vanishing they shine. From the smallest scale to the largest, the same soft thunder echoes. It is a rule written in every layer of reality. The universe, in its immensity, still bends to this simple truth. There is comfort in knowing that something so constant ties together the human and the cosmic. You, sitting quietly and breathing, contain electrons in every atom of your body. The air around you carries particles drifting from cosmic rays. In the right conditions, some of those particles could meet their opposites and vanish, giving off light. The same process happens in stars, in storms, in black holes. You are not separate from the cosmos. You are stitched into its fabric, your being echoing with the same patterns as the galaxies. Annihilation may sound like loss, but really it is connection. The connection of opposites, the connection of scale, the connection of all life to the rhythm of energy and mass. Scientists still wonder whether the mirror of antimatter hides further mysteries. Could there be entire regions of the universe built from antimatter, unreachable to us? If so, their annihilations with stray matter would create light at their boundaries, invisible yet real. Perhaps in some quiet corner of space, antimatter suns shine over antimatter worlds, where beings wonder about their own mirror as we do. We cannot yet know. But the possibility itself is a gentle thought, that the cosmos may be richer than we imagine, that balance may be preserved in ways we cannot yet see. Closer to home, the study of annihilation continues to refine our understanding of symmetry. Physicists ask whether antimatter falls in gravity exactly as matter does. They measure the faintest details of antihydrogen to see whether its spectrum of light matches hydrogen, S perfectly. So far, the mirror has held true. But if one day the mirror cracks, even slightly, it may reveal an opening to new physics, new insights into why the universe is as it is. Annihilation is not only a process, it is also a guidepost, pointing us toward the mysteries still waiting to be uncovered. It is a quiet teacher, reminding us to look closer, to listen more carefully, to wait with patience. There is a tenderness in this waiting. To trap a single anti-atom and watch its behavior requires extraordinary stillness. Magnetic fields curl around it like invisible hands, holding it gently away from the walls it must not touch. One careless vibration and the atom is gone in a flash. To study annihilation, then, is to practice care. It is to approach the most dangerous substance in the universe with respect, with delicacy, with humility. The lesson is as much about how we treat fragile things as it is about physics itself. To hold light in your hands, even for an instant, requires gentleness. And so the story circles back to us. What do we learn from this soft thunder of light? We learn that danger and beauty are not opposites but companions. We learn that endings are not empty but radiant. We learn that the smallest events, an electron meeting a positron, are tied to the grandest fireworks in the universe. We learn that balance is not an abstraction but a living rule that touches every corner of existence. To contemplate annihilation is to contemplate our place in the cosmos, fragile, fleeting, luminous. As the section closes, imagine once more the meeting of matter and antimatter. Picture two sparks drifting toward each other in the dark. They touch, and in touching they vanish. But in their place, two beams of light stream outward, filling the void. They carry on forever, long after the sparks are gone. One of those beams may one day reach an eye, a detector, a world. One of those beams may be what you see when you look at the stars. In that moment, you will be looking at the memory of a meeting, the radiance of opposites, the soft thunder of light that has traveled across time to find you. The story is complete, yet its echo continues. Wherever opposites meet, light is born. Wherever balance holds, beauty remains. And wherever we listen, we find that the universe is speaking in the quiet language of vanishing and radiance, inviting us not to fear its shadows, but to see them as part of the whole. Matter and antimatter meet, and the cosmos whispers again. Nothing is ever truly lost, only changed, only carried onward as light. If antimatter is the mirror and annihilation is the light it leaves behind, then antihydrogen is the first garden we have tried to plant in that mirror world. It is the simplest atom of antimatter, the twin of hydrogen, which itself is the simplest atom of matter. Hydrogen makes up most of the stars you see above you, feeding their fires and shaping their lives. To imagine antihydrogen, then, is to imagine holding the breath of a star's opposite, bottling it carefully so it does not vanish. It is both experiment and metaphor, a way of seeing how deeply the symmetry of the universe runs. Hydrogen is simple, a proton at its heart, an electron circling like a quiet moon. It is the most common atom in the universe, the foundation of stars, the seed from which heavier elements are born in nuclear furnaces. Without hydrogen, there would be no water, no stars, no chemistry as we know it. It is the building block of matter's story. Its twin, antihydrogen, is made of an antiproton at its heart and a positron circling around it. To create it is to assemble pieces that can barely tolerate each other, to coax them into orbit before they meet their fate. It is like trying to hold two dancers apart when every rhythm of the song pulls them toward each other. In the late 20th century, scientists began to dream of this fragile garden. They asked, could we make antihydrogen? Could we build a mirror atom to test whether its properties were truly identical to hydrogen's? The challenge was enormous. Antiprotons are not found lying around. They must be made in collisions of high-energy particles, sifted out from showers of debris, slowed down and captured. Positrons can be created more easily, for example from certain radioactive sources, but they too must be handled with delicacy. Bringing the two together requires not only machinery but patience, fields, and silence. Because the moment an antiproton touches matter, it vanishes. The moment a positron touches matter, it vanishes. The atom must be built in emptiness, suspended in magnetic fields, like a bubble of breath caught in still air. When the first antihydrogen atoms were formed in laboratories, they did not live long. They touched the walls of their containers and disappeared in light. But over time, with new techniques, scientists learned to trap them, to hold them away from matter long enough to study them. They built magnetic bottles, regions of space where invisible fields created valleys in which antihydrogen could drift without touching. In those quiet gardens, antiatoms floated not forever, but long enough to shine back the faintest answers. They absorbed and emitted light in ways that could be measured compared to hydrogen's well-known fingerprints. The results showed what theory had predicted. The twins were, so far, indistinguishable. The mirror still held true. To imagine these experiments, picture a greenhouse built not of glass but of magnetism. Inside it, fragile blossoms of antihydrogen sway. They cannot touch the soil, cannot touch the air. They drift untethered, waiting for light to pass across them. Scientists shine lasers into these gardens, watching how the antiatoms respond. Do they absorb the same colors of light as hydrogen? Do they release the same songs of radiation? So far, the answer is yes. The symmetry is perfect. Yet the act of tending such a garden is an achievement beyond measure. To bottle the breath of a star's opposite, even for a moment, is to hold a piece of the universe's hidden balance. These gardens are not only about symmetry, they are about gravity. One of the oldest questions is whether antimatter falls the same way matter does. Does antihydrogen drift down toward Earth at the same pace as hydrogen, or does the mirror crack under the pull of weight? To find out, scientists in laboratories at CERN and elsewhere have released trapped antihydrogen atoms and watched their fall. The results, still delicate, suggest that they fall just like hydrogen does. But the measurements are not yet final, and the universe may still be hiding a subtle secret. Each experiment is like watching a feather drop in a room where the slightest breath could disturb it. The feather's path tells us not only about itself, but about the rules that govern everything. Holding antihydrogen teaches us humility. We cannot bottle it in jars. We cannot store it on shelves. We can only cradle it briefly in fields of magnetism, in spaces emptied of all else. We can only watch it shimmer for a heartbeat before it vanishes. This fragility reminds us that knowledge itself is fleeting. We hold truths for a time and then they slip away, leaving us with light, with memory, with questions. Yet those brief moments are enough to change how we see the world. A handful of anti-atoms held for seconds tells us that symmetry is real, that the universe has kept its promise. It is a reminder that patience is rewarded, that even the most delicate of gardens can bloom if we wait quietly enough. The beauty of antihydrogen lies not only in its existence, but in what it represents. It is the mirror breath of the stars, captured and studied by beings made of matter. It is proof that the laws of physics extend to the unseen, that the world's balance is not partial but complete. It is also a promise that more secrets lie hidden in the mirror, waiting to be revealed. Every atom of antihydrogen held in a trap is a window into the early universe, when matter and antimatter first danced together in the hot dawn. To study, it is to glimpse those first moments again, to see how the universe chose one side over the other, to ask why we are here instead of gone. As this section draws to rest, imagine a lantern glowing in a glass sphere. The lantern is bright but fragile, flickering if the air shifts, vanishing if the glass breaks. That is what antihydrogen is, a fragile lantern of symmetry, glowing for a moment in the cradle of fields. It teaches us to listen, to wait, to honor the delicate. It teaches us that even the most dangerous substances can be held gently, turned into teachers rather than threats. And it reminds us that balance, once glimpsed, is as beautiful as any star in the night sky. The gardens of antihydrogen are among the most fragile creations ever made by human hands, and yet they may hold answers to questions as old as the stars themselves. To understand their depth, we must wander further into their hidden greenhouses, where invisible walls of magnetism cradle blossoms that cannot touch the soil, where the simplest of atoms is mirrored in perfect symmetry. Here we learn not only about physics, but about patience, fragility, and the quiet persistence of curiosity. Hydrogen in its ordinary form is the seed of the universe. It fuels the stars, joins with oxygen to make water, and builds the chemistry that leads to life. When we imagine its twin, antihydrogen, we are not only thinking of particles arranged in mirror order, we are imagining the possibility that the universe keeps its deepest balance in places we cannot see. To hold antihydrogen is to hold the possibility of confirmation, the chance to test whether the laws of physics remain true on both sides of the mirror. If antihydrogen behaves just like hydrogen, then the universe is a poem written with symmetry as its rhyme. But if it strays, even a little, then the poem hides a twist, a hidden stanza we have not yet read. In laboratories like CERN's antiproton decelerator, antihydrogen is created through processes as delicate as weaving spider silk in the wind. Antiprotons are first born in the violence of collisions, then slowed, cooled, and guided into magnetic traps. Positrons are prepared separately, collected like drifting sparks, and coaxed into contact with the antiprotons. When they bind, antihydrogen is born, but the work does not end there, it is only beginning. The antiatoms must be kept away from the walls of their container, for the slightest touch would erase them in a burst of light. To succeed, scientists build cages of pure fields, invisible lattices that hold the atoms suspended in emptiness. The apparatus hums quietly, more like a beehive than a factory, each coil and magnet working in harmony to keep the blossoms alive. These blossoms do not bloom long, but in their brief lives they allow extraordinary tests. Lasers are shown across them to see what frequencies of light they absorb. Hydrogen's behavior is K. Known with exquisite precision, its lines are etched into our textbooks, measured to the millionth of a fraction. Antihydrogen so far has matched those fingerprints exactly. The mirror seems unbroken. The positron circles the antiproton with the same rhythm as the electron around the proton. Their songs of light match perfectly. It is as if the universe whispers, yes, the symmetry holds, at least here, at least now. But the story does not end with light. Gravity, too, must be tested. For centuries, we have watched objects fall toward Earth. Apples, stones, feathers, all pulled downward by the same gentle hand. Does antimatter fall the same way? If antihydrogen were to drift upward instead of down, if it felt repelled instead of attracted, then the very fabric of our understanding would shift. Such a discovery could rewrite cosmology, could offer reasons for why the universe favored matter in its earliest days. To test this, scientists have dropped antihydrogen in carefully controlled experiments, watching its path with precision instruments. So far, the results suggest that it falls as matter does, obeying the same rule. But the work continues because the universe often hides its secrets in the faintest of deviations, in the quietest of tilts. These experiments remind us of the fragility of knowledge. To hold an atom of antihydrogen is to hold a piece of the universe that should not exist here, a visitor from the mirror side. It is a guest we can only host for a moment, and yet those moments, stacked together, allow us to glimpse truths that once seemed unreachable. It is a reminder that persistence matters more than abundance, that even fleeting encounters can yield lasting understanding. Just as a single word can change a poem, a single measurement of antihydrogen can change our story of the cosmos. Beyond the science lies the metaphor. Gardens of antihydrogen are not gardens in the way we know them. They are not green, not rooted, not fragrant. They are gardens of emptiness where blossoms float unseen. But they remind us of what it means to cultivate, to care for what is fragile, to protect what cannot protect itself. They are acts of trust. Trust that the universe will reveal itself if we are patient. Trust that beauty lies even in the fleeting. Trust that even the most dangerous substance can be handled with gentleness. They teach us that knowledge grows not by force but by tending. The beauty of these gardens is that they are both local and cosmic. In a room beneath the earth, magnets hum softly. Within them, antiatoms drift for moments, yet their story connects to the birth of the universe itself. When the cosmos was young, matter and antimatter filled it equally. They annihilated in pairs, but somehow a sliver of matter remained. To study antihydrogen now is to reach back across time, to ask why the balance was tipped, why we exist at all. Each atom is a relic of that ancient question, a seed that might someday grow into an answer. And perhaps the deepest lesson of all is humility. For all our machines and magnets, we can hold only a handful of anti-atoms at a time. They vanish quickly. They resist capture. They remind us that we are small, that the universe does not give up its secrets easily. But they also remind us that smallness is not weakness. A handful of anti-atoms has already taught us that symmetry holds across worlds. It has shown us that our equations are not dreams but reflections of truth. It has given us confidence to keep asking, to keep listening, to keep building our quiet gardens. So let us rest here among these delicate blossoms and feel their presence. Antihydrogen is not common, not abundant, not enduring, but it is enough to test the mirror, enough to teach us patience, enough to remind us that knowledge grows like a garden, one blossom at a time, fragile but radiant, fleeting but eternal in its meaning. The gardens of antihydrogen, though fleeting, invite us to linger on their meaning. They are not only experiments but mirrors of our own longing to understand. Each anti-atom, suspended in its cradle of fields, speaks softly of symmetry, of balance, of the fragile dance between being and vanishing. To close the story of these gardens, we must wander through the lessons they leave us. Lessons about science, about patience, about beauty, and about our place in a universe built from both matter and its mirror. Picture, if you will, a greenhouse at night. Inside, delicate flowers glow faintly, not because of sunlight, but because of the very energy they contain. Their petals are fragile, their stems nearly invisible. A single touch would cause them to vanish, leaving only a shimmer of light in their place. That is what antihydrogen is like. Blossoms made not of stems and leaves, but of antiparticles, assembled in silence, kept alive only by emptiness. They last but a moment, yet in that moment they change our understanding of everything. When scientists first succeeded in holding antihydrogen long enough to study it, the triumph was not loud. It was quiet, measured in seconds, in the hum of magnets, in data lines on a screen. But in that quiet was a profound victory. We had reached across the mirror and held something that should not exist in our world of matter. To make it linger even briefly was to prove that our hands, though made of matter, could touch the laws that govern both sides. It was proof that knowledge is not only about discovery, but about trust, that the universe, if approached gently, will reveal its secrets. These experiments remind us that fragility is not weakness. Antihydrogen cannot last in our world, yet its existence is powerful enough to test the deepest symmetries of physics. It shows us that balance is not decorative but essential. Without symmetry, equations collapse. Without balance, stars could not burn in harmony, atoms could not bind, life could not arise. Antihydrogen confirms that the mirror is real, that the rules we write are reflections of truths the cosmos keeps faithfully. And yet, even in this perfection, questions remain. Why did matter win in the dawn of time? Why does the universe carry more of one blossom than the other? The gardens give us glimpses, but the full answer is still out of reach. Perhaps that is the beauty of it. If the answers were easy, the wonder would fade. It is the mystery that keeps us tending the garden, coaxing blossoms from emptiness, listening to their faint songs. Each atom of antihydrogen is like a note from an ancient melody, one we have only begun to hear. Together, these notes may someday form a song that tells us why the universe tilted toward matter, why you and I exist to wonder at all. Until then, each experiment is a verse, each success a quiet stanza in the ongoing poem of science. There is also a lesson here about care. To hold antihydrogen requires not force but gentleness. Magnetic fields must be tuned with precision, vacuums must be kept pure, every vibration must be calmed. It is like cradling a newborn bird in your hands, too tight and it perishes, too loose and it slips away. The scientists who tend these gardens are in truth gardeners of fragility, cultivating something that can never be planted in soil or watered with rain. Their work is an act of respect. Respect for the delicacy of the cosmos, respect for the difficulty of truth, respect for the beauty of things that cannot last. In this way, the gardens of antihydrogen mirror our own lives. We too are fleeting, held for a time before we vanish. We too are fragile, yet in our fragility we are luminous. We too are balanced between opposites, life and death, joy and sorrow, light and shadow. To study antihydrogen is to see ourselves reflected in the cosmos, to realize that even the most temporary of things can be meaningful, even the briefest of blossoms can change the world. The anti-atoms vanish, but they leave behind light, data, understanding. We too will vanish one day, but perhaps we can leave behind love, memory, kindness. The physics becomes philosophy once again, teaching us not just about atoms, but about ourselves. Now imagine the dawn of the universe once more, the hot sea of particles and antiparticles swirling together. Most of them vanished in light, but some matter remained. From that remainder came stars, planets, oceans, forests, and you. The story of antihydrogen is the story of that dawn replayed in miniature in the quiet of a lab. Each time we create and hold an anti-atom, we are reenacting the universe's first moments, watching matter and antimatter meet, testing the rules that shaped everything. To study these blossoms is to look backward in time, to glimpse the conditions from which all life sprang. The garden is both a mirror and a memory. As this story rests, let us carry one final image. Picture a lantern suspended in the air, glowing softly, untethered by walls or wires. The lantern is made not of glass and flame, but of opposites held together in delicate balance. It glows only for a moment before vanishing into light, yet in that moment it illuminates everything around it. That lantern is antihydrogen. It is also us, fragile, fleeting, luminous, dangerous, yes, but beautiful beyond measure. A reminder that the universe is not only vast and violent, but also delicate and poetic, filled with gardens that bloom in emptiness and fade into radiance. In the end, the gardens of antihydrogen are not about power, nor about danger, nor even about control. They are about listening to the universe's quiet promises, listening to the symmetry that underlies creation, listening to the fragile notes that tell us we are part of something greater. They teach us that to know is to care, to discover is to protect, to study is to honor. And in their fragile light, they remind us that even the most fleeting blossoms can carry eternal meaning. Deep within the body, where blood flows quietly and cells carry out their secret labors, there are lanterns of light that never existed until science learned to listen to annihilation. These lanterns are not candles, not flames, but flashes born when matter meets antimatter. They are used not to destroy, but to see. They glow for an instant, revealing the hidden patterns of tissues, the activity of organs, the restless hunger of growing cells. To see with annihilation is to transform danger into healing, to turn the most fleeting of vanishings into the most intimate of visions. The story begins with the positron, the twin of the electron. In the ordinary world, positrons are rare. They appear in thunderstorms, in cosmic rays, in experiments, but they do not last long. Yet in the realm of medicine, we have learned to invite them in carefully, using special molecules that release them inside the body. When a positron finds its partner, the electron, they meet in a final embrace and vanish. Two gamma rays fly outward in opposite directions, perfect and balanced. Machines arranged around the body catch this light, tracing the lanterns of annihilation one by one. From these flashes, images are built, pictures that show not just structure but activity, not just shapes but the living fire of metabolism. This practice is called positron emission tomography, or PET scanning, though the name does not capture its poetry. What it truly is seeing with annihilation. Instead of shadows cast by bones or tissues, the body is revealed by the tiny fireworks of particles vanishing. Each annihilation is a word, each pair of gamma rays a sentence, and together they tell a story about life unfolding inside. Doctors read these stories not as scientists alone, but as guides, using them to care for the fragile gardens of the human body. The dangerous becomes the gentle. The fleeting becomes the illuminating. What once seemed to threaten the world becomes a tool for healing within it. To understand the depth of this, imagine walking through a forest at night with lanterns scattered along the path. Each lantern glows for a moment, showing a tree trunk here, a fern there, a bend in the trail beyond. As you move, the lanterns light up where you are, guiding you forward. PET scanning is much the same. The body is the forest. The positrons are the lanterns. The annihilations glow briefly, revealing the hidden terrain. The path becomes visible, not all at once, but piece by piece, until the whole forest can be mapped. In this way, annihilation becomes a guide, not to destruction, but to clarity. The molecules that carry positrons are chosen with care. Often they mimic sugars, for cells love sugar, drawing it in as fuel. Cancer cells, which grow with unrestrained hunger, consume sugar more eagerly than their neighbors. When a positron-bearing sugar enters the body, those cells light up most brightly. Their lanterns glow stronger, marking where growth has gone astray. In this way, annihilation shows not only the presence of life, but its imbalance, its overgrowth, its places of danger. Yet the vision it provides is gentle, non-invasive, a way of seeing without cutting, a way of knowing without harm. It is remarkable to think that annihilation, so feared in imagination, is so quietly helpful in reality. The same process that could release unimaginable energy if matter and antimatter met in abundance now flickers softly in hospitals, helping doctors save lives. It is a reminder that science is not about the raw scale of power, but about how power is used. A match can burn down a forest, or it can light a single candle. Annihilation can be imagined as destruction, or it can be transformed into lanterns that reveal the body's secret places. The images born of PET scans are not flat pictures. They are three-dimensional maps reconstructed from thousands of annihilations. Each point of light is measured, each angle traced, each energy accounted for until a glowing portrait emerges. This portrait is alive, showing where blood flows, where tissues hunger, where healing begins. For a patient, it is more than data. It is a glimpse of the inner self, revealed not by reflection but by vanishing, by the briefest touches of opposites dissolving into light. The mirror world, for an instant, shines through the body. To see with annihilation is also to see the unity of scales. The same process that guides doctors is the same process that lights up the cosmos in gamma-ray bursts, the same process that fills the upper atmosphere with flashes during storms, the same process that plays out in laboratories with magnets and traps. From the smallest cell to the largest galaxy, annihilation writes the same poem. Matter meets its twin, vanishes, becomes light. We are linked to the stars by this rule, stitched into the cosmos by the same luminous thread. In every PET scan, the patient becomes part of that cosmic rhythm, carrying the song of annihilation in their very body. There is something deeply comforting in this, to know that your body can be seen, not by cutting or piercing, but by listening to its own gentle lanterns, is to feel that science has learned to respect fragility. The patient is not invaded but revealed. The light comes from within, born of processes too small to feel, too fleeting to disturb. The body speaks in whispers of light, and the machines listen patiently, building meaning from silence. This is what it means to see with annihilation, to transform danger into tenderness, to turn physics into medicine, to use the mirror world not to destroy but to heal. As this section closes, hold the image of those lanterns. Picture 1,000 tiny lights glowing deep inside, not steady like lamps, but flickering like fireflies. Each glow is a meeting, each meeting a vanishing, each vanishing a revelation. Together they form a constellation within you, a map of your living body, drawn not by ink or shadow but by light itself. And in that constellation, you can see the quiet truth, that even the most dangerous of forces can become the gentlest of guides, if only we learn how to listen. To walk deeper into the story of annihilation in the body is to wander through corridors of science that feel at once clinical and poetic. We have seen how positrons become lanterns of light, showing us the hidden rhythms of tissues. Now let us linger longer in this space, tracing how these quiet vanishings allow us to see illness, to follow healing, and to glimpse the unity between our fragile lives and the vast cosmos. The lanterns flicker not only as images on a screen, but as symbols of transformation, teaching us that even in disappearance there can be clarity. At the heart of PET scanning lies the patient's own living chemistry. Tracers, built to resemble the body's favorite fuels, are introduced gently. Most often they mimic sugar, the simplest energy for cells. Once inside, the tracer is taken up wherever cells are most active. When a positron escapes from one of these tracers, it drifts only a tiny distance before it meets an electron. Their union is brief, their vanishing instant, but the gamma rays that emerge fly outward like tiny messengers. Two streams of light, born from nothing more than an embrace of opposites, carry information about where in the body life is burning brightest. And in this way, the body speaks for itself. Consider how remarkable this is. A tumor deep inside, unseen by the eye, unmarked on the skin, lights up as surely as a lantern on a dark path. Not because the tumor is touched directly, but because its hunger for sugar makes it glow more strongly in annihilation. The doctor does not see the tumor itself. The doctor sees the lanterns it leaves behind, the quiet thunder of light where positrons vanish. The image is not a shadow cast from the outside, as with X-rays, but a glow from within, as though the body itself were whispering its secrets in photons. To see illness this way is to turn destruction into diagnosis, to use the fleeting touch of antimatter as a guide to care. But PET scans are not only about finding illness, they are about following life itself. They can show how the brain consumes energy while we dream, how the heart beats stronger in one chamber than another, how healing bones rebuild themselves after injury. In research, PET has been used to map thought and memory, to watch the brain's lanterns flicker while a person speaks, listens, or remembers. The annihilations become stars in a constellation of the mind, each one telling where neurons fire, where energy flows, where consciousness itself stirs. To see with annihilation, then, is not only to see sickness, but to glimpse the workings of life's most delicate machinery. Step outside the hospital, and the poetry deepens. The very same annihilations that give us medical images also occur in the sky, in thunderstorms, in galaxies, in the vacuum itself. To realize this is to feel the body as part of the cosmos. The light that doctors read is the same kind of light born when cosmic rays strike the atmosphere, the same light born when stars collapse, the same light that has traveled millions of years to reach our detectors on Earth. To see with annihilation is to join a rhythm that stretches from the cell to the star. It is to realize that the lanterns glowing within you are cousins to the lanterns glowing in distant space. The careful design of PET scanners reflects this unity. Rings of detectors encircle the patient like a halo of listening ears. They wait silently for the photons, counting each arrival, measuring each angle. Computers then reconstruct the paths, turning them into an image. From chaos emerges pattern, from vanishings emerges clarity. The patient lies still, unaware of the countless annihilations flickering within, unaware of the photons flying outward, unaware of the story being written in silence. Yet in those moments, the patient's body becomes a cosmos of light, a small universe speaking in F. Lashes that machines can hear. The hospital becomes an observatory, the body a sky, the annihilations the stars. It is worth pausing here to feel the gentleness of this process. Annihilation might sound violent, yet in the body it is silent, painless, unfelt. The patient feels only stillness, perhaps the coolness of the room, the presence of the machine. The annihilations pass unnoticed, yet their meaning is immense. They are proof that physics, so often thought of as distant and abstract, touches our lives in the most intimate ways. They are proof that the boundary between science and care is thin, that the same rules that govern galaxies can also guide healing hands. The lanterns of annihilation are, in truth, lanterns of compassion. Imagine for a moment that you could see these lanterns with your own eyes. Picture a person walking into the scanner, lying down and closing their eyes. Then imagine the positrons flickering inside, tiny sparks meeting electrons, glowing in annihilation. You would see a constellation blooming within the body, glowing brighter where cells are most active, dimmer where they are calm. You would see the brain like a night sky alive with stars. You would see the heart glowing with steady rhythm. You would see the hidden gardens of life lit not by external light, but by the body's own physics. This is the poetry hidden in every PET scan, the universe's deepest rule made visible in the most personal of ways. The lesson is clear. Annihilation is not only an end, it is a beginning of sight, of understanding, of healing. It is a bridge between danger and care, between physics and medicine, between the cosmos and the body. To see with annihilation is to learn that nothing is wasted, not even the vanishing of particles. Their disappearance becomes a gift, their light a guide. And in that gift lies hope, not abstract, but real, carried into the lives of patients every day. As this section rests, imagine again the forest path lit by lanterns. Now imagine that forest is your own body, alive with countless trails, countless trees, countless clearings. The lanterns glow along the way, guiding, revealing, comforting. They are born of annihilation, yet they serve life. They vanish in an instant, yet they leave behind images that endure. They remind us that even in disappearance there is meaning. Even in danger there can be healing. Even in the mirror world there can be gentleness. And in those lanterns we see not only ourselves, but the whole universe reflected softly back. The lanterns of annihilation within the body are more than instruments of medicine. They are metaphors of existence. In their glow, we find lessons about fragility, resilience, and the way light can emerge from endings. To close this story, let us wander slowly through the meanings these lanterns leave us, reflecting on how the vanishing of particles has become a source of vision, and how that vision connects us to the wider universe. Think first of the paradox. Annihilation sounds like destruction, a vanishing into nothing. Yet when a positron meets an electron, nothing is truly lost. Instead, their mass transforms into light, two balanced beams streaming away in opposite directions. What looks like an end is really a transformation. In this way, annihilation is a teacher. It shows us that endings do not need to be feared, that disappearance can carry on as radiance. The lanterns glowing within a PET scan embody this truth. They vanish, yet they illuminate. They leave behind not emptiness, but clarity. In their brief flash, they give us a new way of seeing. Now extend this metaphor to the human journey. We too are fleeting. Our lives burn for a time, then vanish into memory. Yet what we leave behind, our light, can endure. Just as photons from annihilation travel outward, carrying the memory of vanished particles, so too do our actions, our kindnesses, our words travel beyond us. We vanish, but the echoes of our presence remain, illuminating the paths of others. Annihilation reminds us that we are not defined only by our endings, but by the light that continues after us. In the hospital, when doctors look at the images born from annihilation, they see more than glowing organs. They see hope. They see the possibility of healing. They see guidance for treatment, clarity for decisions, reassurance for patients. For those lying still in the scanner, the lanterns are silent companions, flickering deep within, unseen by their own eyes but shaping their care nonetheless. Each photon that reaches a detector carries with it a message. Here is life, here is energy, here is where attention is needed. In this way, annihilation becomes not only science but compassion. It allows us to look inside without harm, to learn without breaking, to see without cutting. It transforms physics into kindness. Beyond medicine, the lanterns link us again to the cosmos. The photons born in a patient's body are the same kind of photons born in tea. Thunderstorms above the Earth, the same photons that blaze from the hearts of galaxies, the same photons that have traveled across millions of years from distant annihilations in space. To realize this is to feel unity. The body is not separate from the universe. It glows with the same processes, speaks with the same light, belongs to the same story. When you see images of your own body made from annihilation, you are looking at echoes of the same law that lights up the stars. You are seeing yourself as part of the cosmos, stitched into its balance of matter and antimatter, woven into its luminous fabric. This connection carries comfort. It tells us that the universe is not distant or indifferent. Its deepest rules live within us. The same annihilations that shape galaxies flicker quietly in our cells, helping us see ourselves more clearly. The cosmos has lent us its light as a gift, allowing us to turn danger into healing, disappearance into vision. To carry this thought is to feel at home in the universe, to know that the lanterns inside your body are kin to the lanterns scattered across the sky. There is also humility here. The positrons we use in medicine do not last. They vanish almost instantly, and yet in their vanishing they give us knowledge beyond measure. Their fragility is their gift. In this way they teach us to value the fleeting, to recognize that even what does not endure can still carry great meaning. The lanterns remind us that permanence is not required for importance. A single flash can light the way. A single act can change a life. A single annihilation can reveal the workings of the body. Fragility, far from being weakness, is often the very source of beauty. Imagine once more the body as a forest at night. In the first section, we saw lanterns along a path. In the second, we saw constellations glowing within. Now at the end, imagine stepping back and seeing the entire forest from above. The lanterns are everywhere, scattered like stars, forming a map of life. Each glow is brief, but together they create a picture that is whole, a vision that guides us. The forest is not dark, but illuminated by countless fleeting lights, each one gone in an instant, but leaving behind clarity for those who watch. That forest is you. That constellation is your body. And the lanterns are the quiet thunder of annihilation, transforming invisibility into sight. As this story closes, hold this final reflection. Annihilation, feared as the most dangerous of processes, has become one of the gentlest. It reveals, it guides, it heals. It reminds us that endings can shine, that fragility can teach, that light is born wherever opposites meet. The lanterns inside the body are not only tools of science, they are symbols of life itself, luminous reminders that even in vanishing there is beauty, and in their glow we find not fear but wonder. When we look at the night sky and ask why there is something instead of nothing, we are asking about dawn, the first dawn, when the universe was young, filled with fire and balanced between opposites. Matter and antimatter were born together, perfect twins, destined to meet and vanish. By every calculation, they should have erased one another completely, leaving only light, an endless ocean of radiation without stars, without planets, without us. And yet here we are, something tipped the balance. Something allowed matter to survive its twin. That missing half of dawn is the mystery that has haunted physics for a century. It is the reason you can lift your eyes to see stars, the reason oceans roll, the reason breath fills your lungs. Without it, the universe would have been empty. The dawn would have been silent. Imagine the first second of creation. The universe is hotter than any star, denser than any core, filled with particles flashing into existence. For every electron, a positron. For every proton, an antiproton. For every particle of matter, an equal particle of antimatter. They swarm like fireflies in a storm, colliding, vanishing, releasing light, then reappearing again from the energy. It is a dance of creation and erasure, a rhythm that should have led to nothing but photons, nothing but brightness without form. And yet the dance was imperfect. For every billion pairs of matter and antimatter that annihilated, one particle of matter was left unmatched. That 1 in a billion imbalance is the seed of everything, the galaxies, the planets, the rivers, and your own beating heart. The reason for that imbalance remains one of the deepest questions in science. We call it baryon asymmetry, the preference of the universe for matter over antimatter. Why it occurred, we do not yet know. It is as if the mirror cracked at the very beginning, tilting just enough to leave a residue of matter behind. Some believe the answer lies in subtle violations of symmetry, tiny differences in the way particles and antiparticles behave. Others believe the answer may lie in physics we not yet discovered hidden rules that shaped the dawn. Whatever the reason, it is the reason we exist at all. We are children of imbalance, beings made from the leftover half of creation. Consider how delicate this imbalance was. 1 part in a billion. If the scales had tipped the other way, the universe would have been annihilation without remainder. No atoms, no molecules, no stars, only radiation drifting forever through emptiness. The fact that we exist is proof that the dawn chose matter, or perhaps it is proof that chance played its hand and we are here by the narrowest margin. Either way, the missing half of dawn is written in every stone, every tree, every thought. You are the evidence that the universe was not perfectly fair, that symmetry broke, that matter survived. Scientists search for the fingerprints of that broken symmetry. They study rare particles like kaons and B-mesons, which sometimes show a faint preference for matter over antimatter. In these subtle decays, the mirror winks, showing that nature is not perfectly balanced after all. These faint tilts may be the echoes of the imbalance that saved us. To study them is to listen for whispers from the first second of time, to catch the faint echo of dawn itself. In vast laboratories, detectors wait in silence, watching billions of events to catch the rare moment when a particle betrays the mirror. Each of those betrayals is a clue, a fragment of the story of why the universe chose us. The missing half of dawn is also a reminder of fragility. The universe did not need to tip in our favor. It could easily have remained empty. Our existence is not inevitable. It is improbable, delicate, precarious. To live is to be part of that unlikeliness. To breathe is to carry within you the story of imbalance. To look at the stars is to see the consequence of asymmetry. Every galaxy is a monument to imperfection. Every sunrise proof that the universe bent ever so slightly away from symmetry. Without that tilt, dawn would have been missing not only antimatter, but everything. Yet there is also comfort here. If the universe is not perfectly symmetric, if its balance can break, then creation can occur. Perfection, it seems, is sterile. Imperfection is fertile. The crack in the mirror is not a flaw, but a doorway. It is what allowed matter to remain, what allowed atoms to join, what allowed life to rise. The missing half of dawn is not a tragedy, but a gift. It is the quiet reason that love, music, and memory exist. It is the reason there are fields and forests and seas. The universe did not choose emptiness. It chose imperfection, and from imperfection came everything. As this section rests, hold this image, the first light of dawn spilling over the horizon. Half of it is missing, lost in annihilation. But the half that remains is enough to paint the sky, enough to warm the earth, enough to sustain life. We are living in that remaining half, children of imbalance, born from the sliver of matter that survived its twin. The missing half of dawn is not absence, but context. It is what makes presence meaningful. And in its mystery lies the most beautiful of questions. Why did the universe choose us? To linger on the mystery of the missing half of dawn is to linger on the very edge of knowing. We stand at the boundary between what we can measure and what we can only imagine, trying to understand why matter won its narrow victory. In the silence of that first second, the universe made a choice, or perhaps a mistake, or perhaps it followed laws we have not yet discovered. Whatever the reason, the faint tilt away from symmetry became the foundation of everything. To follow this story deeper is to follow not only physics, but philosophy. It is to ask why the crack in the mirror gave rise to life, and what it means that perfection was broken so early in creation. The search for answers begins with symmetry itself. In mathematics and physics, symmetry is more than beauty, it is structure. Equations are often written to preserve balance, to ensure that one side reflects the other. In the world of particles, this symmetry means that for every quark there should be an antiquark, for every lepton an antilepton. When Paul Dirac's equation predicted the positron, it was symmetry that spoke through the mathematics. When experiments later confirmed the antiproton and the antineutron, symmetry was proven once more. Yet the universe we see is not symmetric. It is built almost entirely of matter. The antimatter that should exist in equal measure is gone, annihilated in the dawn. Why symmetry faltered, why the balance broke, is one of the greatest puzzles of cosmology. Physicists have looked to the weak nuclear force for hints. Unlike gravity, unlike electromagnetism, the weak force is strange, asymmetrical. In certain rare decays of particles called kaons and B-mesons, experiments have found that matter is favored slightly over antimatter. This preference is called CP violation, short for charge parity violation, meaning that the mirror of matter and antimatter is not exact. These small tilts are like whispers from the first second, echoes of the imbalance that saved us. Yet the tilts we have measured so far are too small to explain everything. They cannot account for the 1 in a billion survival that gave rise to galaxies. The universe must be hiding more secrets, more broken symmetries, waiting for us to uncover them. Some theories suggest that the answer lies in leptogenesis, a process involving neutrinos, those ghostly particles that pass through our bodies by the trillions each second. If neutrinos once behaved differently than antineutrinos, then they could have tipped the scales at dawn. Neutrinos are still mysterious today, with masses so small we can barely measure them, and behaviors that surprise us. If they are the key, then the missing half of dawn may be written in the language of these shadows, the faintest of particles shaping the fate of the entire cosmos. Other theories look to physics beyond the standard model, to forces and particles we have not yet imagined, to laws that lie hidden beyond our current reach. The answers may be waiting in future experiments, or they may be written in the light of the cosmos itself, still traveling toward us from the earliest times. To ponder this is to feel both awe and humility. We are here because the universe broke its own balance. We are here because something was imperfect. If symmetry had held, if every particle had found its twin, the cosmos would be empty. In the silence after the Big Bang, the universe chose imperfection, and imperfection became creation. It is a lesson we can carry beyond science. That perfection is not always life-giving, that balance without deviation may yield only emptiness. It is the crack, the tilt, the imbalance that allows the world to exist. Stars are born from instability. Galaxies form from unevenness. Life grows from imperfection. The missing half of dawn is proof that even the smallest deviation can carry the weight of universes. Now imagine again that early fire. Matter and antimatter swirl in perfect pairs. They vanish in flashes of light over and over until only a thin residue of matter is left behind. That residue cools, gathers, forms atoms, clouds, stars, and planets. The imbalance is magnified, spreading outward in time until it becomes all of creation. You are made of that residue, of those survivors. Your body, your thoughts, your very awareness are the continuation of an ancient symmetry. To feel this is to feel connected not only to the stars, but to the very dawn of time, to the fragile moment when existence itself was decided. This connection shapes how we see ourselves. We are not separate from the cosmos. We are its outcome, its children, its consequence. The missing half of dawn lives in us. Every breath, every heartbeat, every dream is part of the story that began when matter outlasted antimatter. To know this is to live with a kind of gratitude for the imbalance, for the imperfection, for the fact that the universe did not cancel itself out. Gratitude not only for existence, but for the chance to wonder about existence at all. To ask these questions is itself proof of the asymmetry. The universe tilted, and in tilting, it created beings who could reflect upon the tilt. The mystery is circular, recursive, poetic. In laboratories, scientists continue to chase the missing half of dawn. They build machines that accelerate particles to near the speed of light, smashing them together to recreate conditions of the early universe. They watch for tiny violations of symmetry, for patterns that might reveal why matter survived. They measure neutrinos traveling beneath the Earth, waiting for the faintest sign of imbalance. Each experiment is like a listening post, waiting for the dawn to speak again. And though the answers remain incomplete, the pursuit itself is a kind of prayer, a way of honoring the mystery by leaning toward it with patience. As this section rests, picture dawn itself, the moment when the horizon brightens though the sun is still hidden. Half the light seems missing, yet the world is illuminated. That is the universe's story. Half of its birth vanished, annihilated, but the half that remained was enough. Enough to create stars, enough to create life, enough to create the questioners who now look back and ask why. The missing half of dawn is not gone. It lingers as mystery, as poetry, as the quiet reminder that imperfection is the root of being, and in that imperfection we find meaning. The missing half of dawn has carried us from the first fire of the universe to the delicate questions of symmetry, from the survival of matter to the search for why. Now, in this final reflection, let us rest with what the mystery means, not only for science, but for our sense of existence. For to speak of imbalance is to speak of ourselves. We are, each of us, the living echoes of that tilt in the mirror, the residue of a dawn that should have vanished but did not. Imagine again the first horizon. The universe has just been born. It is heat and brilliance, particles flashing into existence. For every quark an antiquark, for every electron a positron. They meet, they vanish, they fill the cosmos with light. But in that endless rhythm of annihilation, a faint difference emerges. A few particles of matter remain unmatched, slipping through the cracks of symmetry. It is such a small difference, 1 in a billion, but it grows. That residue becomes the universe we see, the stars that burn, the planets that circle them, the lives that awaken to wonder at it all. From the perspective of mathematics, it is almost nothing. From the perspective of being, it is everything. We search for reasons, and perhaps one day we will find them. We measure neutrinos with patient detectors buried deep underground, hoping to catch a whisper of imbalance in their flight. We watch mesons decay, counting the ways matter is favored over antimatter. We build accelerators to recreate moments of the early fire, trying to glimpse the laws that govern dawn. But even if the answer remains hidden, the mystery itself is a gift. It reminds us that we live not in a universe of certainty, but of questions. It reminds us that knowledge is not a closed circle, but a path that opens further with every step. The missing half of dawn is not only a problem to solve, it is an invitation to keep wondering. There is a lesson here about imperfection. We are often taught to admire symmetry, to strive for balance, to believe that perfection is the ideal. Yet the universe tells another story. It tells us that without imbalance, nothing would exist. Perfect symmetry would have erased everything. Perfection would have left only silence. It was imperfection that created stars, imperfection that allowed life, imperfection that allowed love, memory, and thought. To exist is to be a child of asymmetry, a creature of the broken mirror. The missing half of dawn is proof that flaws can be fertile, that cracks can be creative, that imbalance can be beautiful. Think of your own life in this light. You too are not perfect symmetry. You are uneven, sometimes in harmony, sometimes in conflict, carrying light and shadow, strength and frailty. Yet it is precisely this imbalance that makes you alive, that makes you human. If you were perfectly balanced, without contradiction, you would not change, you would not grow, you would not feel. The lesson of the universe is written in your very being. It is the imbalance that gives rise to meaning. The missing half of dawn is not only the reason atoms exist, it is the reason you can love, the reason you can grieve, the reason you can dream. In the cosmos, the consequence of that ancient tilt is written across the sky. Every galaxy is a monument to imbalance. Every star is a survivor of dawn's broken symmetry. Every planet, every ocean, every forest is part of the residue left behind. To look at the night sky is to see the aftermath of the missing half of dawn stretched across billions of light years. And to know that you are part of that aftermath is to feel both small and infinite. Small because you are a single life in a vast cosmos. Infinite because your life is woven from the very fabric of that first imbalance, a thread in the tapestry that began when dawn chose imperfection. Perhaps the universe did not choose at all. Perhaps the imbalance was chance, the random outcome of quantum fluctuations in the earliest moment. Or perhaps there is a law still unknown that required matter to win. We cannot yet say, but whether it was chance or necessity, the meaning is the same. We are here. We are the survivors of the dawn, the children of the mirror's crack, the bearers of existence in a cosmos that could have been empty. To live with this knowledge is to live with gratitude, to carry within yourself the awareness that your very being is improbable, delicate, and precious. As this story comes to its end, imagine dawn itself, not of a day, but of the universe. The sky is not yet formed, but light is rising. Half of it has vanished, annihilated, but half remains. That half is enough. It paints the stars, it fills the oceans, it gives rise to voices that can ask questions in the night. We are that half. We are the residue of imperfection, glowing softly in the silence of space. And though the missing half of dawn may never be fully explained, its absence is what makes presence possible. Its mystery is what makes life meaningful, and in that truth we find peace.